Let's take a look at this problem. A boat can travel 54 miles per hour in still water. If it travels 126 miles with current in the same amount of time it travels 90 miles against current, what is the speed of the current? Okay. And if it travels 126 miles with current in the same amount of time it travels 90 miles against the current, what is the speed of the current? In the same amount of time. Okay. Now our distance is equal to r times t, and then this is we're talking about with the current and against. So I'll put W for with. Then the other one will also have its own d is equal to r times t, and that's against. I'll put A for against. And it says that notice the wording. It travels if it travels 126 miles with current in the same amount of time. So it's telling you t is the same. Well, if I solve this for t, this would be d over r is equal to t. And I'll put w's here to indicate with the current. In this one, if I solve for t, I get d over r, and I'll put a for against the current equals t. Since the t's are the same, then I can set these fractions equal to each other. So we got this right here. Try it again. R down there. Okay, so let's see what they give us exactly. Now, I struggle with these a little bit myself. I haven't worked these ahead of time. This is all on the fly. Sometimes I set it up wrong, and then I have to rework it, and with the correct setup. It says a boat can travel 54 miles per hour in still water. Okay, if it travels 126 miles with the current. Okay, so the distance is 126, and our rate of speed, well, it's 54 with the current. Now, with the current makes me think it should travel faster because you have the current at your back. So I'm going to say this is 54 plus the speed of the current, s. Now, sometimes that's 54 minus s, and I'm not reading it correctly. Let's see, with the current in the same amount of time it travels 90 miles against the current. So this would be 90. And against the current, you take your 54 miles per hour that it goes minus the speed of the current. So minus s. Now my s's are horrible, so I'm going to change those to x's. But keep in mind what s represents, speed of the current. So we got 54 plus x equals 90 over 54 minus x. Now this is a proportion, single fraction equal to single fraction, so I cross multiply. So we got 90 times 54 plus x equals 126 times 54 minus x. 90 times 54. Gives us 4860. 90 times x is 90x. 126 times 54. Gives us 6804. And 128 times negative x gives us negative 126x. Now I want to get everything with an x on one side and numbers on the other side, so I'll take negative 126x over here and take 4860 over here. So I have everything with x on the left side. So we got 90x plus 126x equals 6804 minus 4860. And what is that, 216x? Yeah. Equals 6804 minus 4860. And that gives us 1944. Divide both sides by 216. And let's see what we get. X, which represents speed of our current, we have 1944 divided by 216. And that gives us 9. And of course, it'd be 9 miles per hour. And that seems to make sense then. So 54 plus 9, that means that's going 63 with current at your back. 54 minus 9 gives us, what was that, 45? So you got 45 since current's working against you. Let's make sure that's what they're asking for. Sometimes I don't read a problem close. What is the speed of the current? Okay, so that's what we found. Now, if I had come up with like a negative 9, for example, that would have told me that I did the setup wrong over here. That instead of a plus here, it should be a minus. And over here, instead of this being a minus, it should be a plus.